It can be useful to take the product of two trigonometric functions and rewrite it not as a product but as a sum. So how do we do that? Let's take a look at two trigonometric identities that we know. The sum formulas for sine. And if we add the first and the second, what do we get? On the left-hand side, we have the sine of alpha plus beta plus the sine of alpha minus beta, and that will equal 2 sine of alpha cosine of beta, and then the remaining terms add to 0. So we can go ahead now and divide both sides by 2. So on the left-hand side, we will obtain 1/2 of the quantity and on the right-hand side we will have sine of alpha cosine of beta. So we can think of this as taking our product, sine alpha cosine beta, and rewriting it as the sum of our trig functions. If we add for the cosine, something similar will happen. We will have cosine of alpha minus beta plus cosine of alpha plus beta, and this will equal 2 cosine alpha cosine beta, and the remaining terms add out. And again, we could go ahead and take half of both sides and obtain our next product to sum formula. And then we have one more that we can do. So we start off with the same 2 in our last slide, but this time we're going to subtract. And if we do that, we obtain cosine of alpha minus beta minus the cosine of alpha plus beta, and this will equal, this time our first terms add to 0, and in our last terms we'll give 2 sine of alpha sine of beta. So this will yield for us the sine of alpha, the sine of beta. That product can be rewritten as 1/2 cosine of alpha minus beta minus the cosine of alpha plus beta. And so we have 3 more identities to memorize. So notice if I have 2 trig functions that are the same, sine or cosine, then those came from the sum and difference formulas for cosine. However, if I see a mixture of sine and cosine, I use the sum and difference formulas for sine. So again, I don't memorize these, I just remember how to derive them. You can do the same, it's up to you, but you need to have them known, and known quickly. So let's look at an example. Here we have cosine of 135 degrees times the cosine of 15 degrees. So our formula for that is the cosine of alpha, the cosine of beta, equals 1/2 of cosine of alpha minus beta plus cosine of alpha plus beta. And so we obtain cosine of 135 degrees, cosine of 15 degrees will equal 1/2 of the cosine of 135 degrees minus 15 degrees is going to be 120 degrees. Plus, now if we add the angles, we get 150 degrees. And so we have 1/2, and the cosine of 120 degrees is the same as the reference angle, but now in the second quadrant. And the reference angle is 60 degrees. And so cosine of 60 degrees is 1/2. In the second quadrant, we end up with -1/2 plus cosine of 150 degrees will be the cosine of 30 degrees, but we'll have an angle in the second quadrant. So it will be negative square root of 3 over 2. So if we simplify this, we obtain 1/2, and that will be -1 minus root 3 over 2. So we have -1 minus the square root of 3 all over 4. Now in this example, we want to take sine of 2 theta and cosine of 4 theta, multiply those, and rewrite it as a sum. So sine of 2 theta, cosine of 4 theta fits the pattern for sine of alpha, cosine of beta, which will be 1/2 of sine of alpha plus beta plus the sine of alpha minus beta. So the sine of 2 theta cosine of 4 theta will equal 1/2 of the sine of, now let's add them, 2 theta plus 4 theta is 6 theta, plus sine of, now 2 theta minus 4 theta is -2 theta. But now we have the availability of our even and odd functions. So sine is an odd function. So since it's an odd function, the sine of a negative angle is the negative sine of the angle 2 theta in this case. And thus we have our answer.